Hello everyone. The objective of this talk is to report our approach in designing an explainable AI based solution for livestock mart industry. Before we jump into our approach, let me briefly present the use case of livestock mart industry. This use case is derived based on the discussions and meetings with MartEye, a startup based in Portershed in Galway City, Ireland. The objective of an online mart is to match buyers and sellers to weight animals and to oversee their sale. To ensure fair and just pricing of the animal, it is essential to understand data that determines their true value. It is also used in careful modeling and appropriate transparency considerations for valuation and pricing of animals that should aid in stopping kickbacks, exorbitant commissions, and price manipulations. A reliable pricing method can be developed by machine learning models that can read through historical sales data running into millions. It provides a valuable and unbiased tool for pricing of the animal at a livestock mart. This slide shows a typical machine learning life cycle to predict the price of an animal at live mart. A model is built during the training phase using the corrected data at the model training stage. Then the trained model is deployed in real world for the price prediction. However, the problem with this approach is that it does not reveal too much about the quantities and the abilities of an animal when AI model predicts a price. In other words, the deployed model remains the black box for the buyers how the predicted price of an animal is derived. An interested buyer would like to know more about the salient features of an animal before making the right choice based on his requirement. A model capable of explaining different factors that impact the price point is essential for the needs of the market. It can also inspire confidence in buyers and sellers about the price point offered. To achieve these objectives, we have been working on building a smart video analytic platform leveraging explainable AI techniques. In the next couple of slides, we are going to present this approach. Let me first talk about the video-based feature extraction module. The video-based feature extraction module extract several features from an animal image such as weight, age, height by applying classical computer vision and CNN based vision techniques. Let me demonstrate an implementation of this feature in Colab. So this is our implementation. First, we import all required packages and files. Thereafter, we take the input video to extract the best image frame out of it, and thereafter we evaluate different features using that image frame. Okay, so this is input video that we have taken as an input, and then we have extracted the best frame using YOLO version 3. Thereafter we have constructed a function which evaluates two parameters important for determining weight, that is body length and heart width. Body length is calculated by taking distance from the midpoint to the object end point in horizontal direction. Heart width is nothing but the circumference. Circumference can be approximated as 1/8 of the distance computed from midpoint to the object top vertically, and finally the body weight is evaluated as heart width multiplied by heart width multiplied by body length multiplied by scaling factor divided by 300 as we are evaluating in LBS. Now let me talk about ML based price prediction module first, and then we will look at the implementation. So ML based price prediction module interact with video based feature extraction. We have trained a multivariate linear regression model using a historical dataset provided by the MartEye team. The deployed regression model takes features and predicts the price recommendation of an animal to buyers at Mart. The team has collected large datasets from different Mart across Ireland. The dataset contains 20 plus features such as price per kilo, weight of an animal, and this model is trained by considering the total price of an animal as target variable and the remaining feature as independent variable. Let me demonstrate an implementation of this feature in Colab. So in our model training, first we perform all required exploratory data analysis on our data set and keep only the desired attributes. And next we divide the data set into train and test set. Further, we apply multivariate linear regression model for price prediction. So this is how the ML based price prediction is carried out. Now let me talk about the Explainable AI module, which is our third and last module. So in our Explainable AI module, we generate price recommendation with explanation describing how the recommended price is derived with explanations. Instead of just predicting the price, we employ several existing model interpretation techniques to generate insight from the ML based price prediction model. This slide shows the explanations generated by Lime, which is a list of explanation considering the contribution of each feature to predicted price value. So Lime is local interpretable model agnostic network and which uses ML based price prediction model. Let me demonstrate an implementation of our Explainable AI module in Colab. So the last module is Explainable linear regression with Lime. We install Lime using pip, and next Lime tabular explanation are applied, which are generated first, which generate neighborhood data by randomizing features, then learn locally weighted linear models to explain each class in an interpretable way. This is how it is implemented with respect to weight, PPK and total price. Predicted value lies in between 257 to 1533. Weight has a positive impact if it lies between 355 to 458, and PPK has a positive impact if it is greater than 222. Thank you. I really appreciate that you took the time to listen to this presentation. Thank you once again.